Hello everyone, welcome to Mr. Schultz's Integrated Math 1 class. Make sure you write your information in the top left and right hand corners, and we're going to be talking about 4-6, piecewise and step functions. So we're going to talk about step functions first up. Basically, step functions are kind of like linear graphs, but they're not. They tend to plateau, and then they take a step, and they plateau, and then they take a step up, and they plateau. So basically, it looks like steps. So look at this. This is an excellent example. The cost of postage for a letter. So for example, hey, if it weighs between this amount, like let's say it weighs 1.5, well then it costs 41 cents. Well, what if it weighs 41 cents? Or 41, I'm sorry, what if it weighs 1 ounce? Well, it's not going to cost 41 cents, it's going to cost 39 because it costs a certain amount and then it jumps up and costs a certain amount, like it goes up to 2, but after 2, if it's like 2.0000001, and that's why we have this open circle right there. We have the open circle. It gets really, 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 really close, but it's not going to include it. So right here, it looks like it hits 2 points, like between here and here, but it doesn't. It just gets really close because it gets to the idea of, hey, look, it's going to get really, really close to 2, but not be it. For example, if it's at 2.0000001, it's not going to cost 41 cents. It's going to cost 43 cents now. So I'm going to post a video on stepwise, but you don't have to worry as much. This is like one of my favorite graphs, but it's not really important in the grand scheme of things. All right, let's go on. So composite areas. So if we're going to be adding certain shapes that we can't figure out the formula, like there should be a formula to figure this out, but maybe we don't have it, maybe we don't know it. Well, we can literally cut these forms into parts that we do understand. So we can figure out what's the area of the triangle plus the area of the rectangle. So, the triangle plus the rectangle will equal the total area. So the area of the triangle plus the area of the rectangle would equal the total of the whole thing put together. Now we just have to figure out the sum of its parts. So if you can't figure it out by itself, break it into its pieces and figure out that. Why am I bringing up this review from a previous grade? Well, that's what we talk about piecewise. Sometimes a function is more than just one equation. To graph these piecewise defined functions, by the way, we put the fun in functions. To graph these piecewise, we should graph each piece separately. That means, hey, look, for example, we want to graph this equation. All right, well, 2x plus 4 when x is less than or equal to 1, and when f of x is equal to negative x plus 3 when x is greater than 1. Well, we would just need to make our x, y tree table, and then we just plug in some information, like, hey, let's plug in 3. 2 times negative 3 is negative 6. Negative 6 plus 4 is negative 2. Plug in negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 4 is 0. Okay, just keep going through this. Negative 1 times 2 is negative 2 plus 4 is 2. And it looks like, hey, we're going to add 2. For every 1, we add 2. For every 1, we add 2. And this makes sense because this is a linear equation. How do we know? Because it's in slope-intercept form. So it's a line. Next up. Now, it says we want to go to 1 and include it. So when x is 1, we would hit 6. Well, now all we need to do is we graph it. So at negative 3, it's going to be at negative 2. Cool. At negative 2, it's at, I put positive 2. That's all right. Let's erase that. All right, -2 right there. And then at -2, it's at 0. At -1, it's 2. 0 is 4. And then 1 is going to be at 6, which should be right about there. Now, are we going to fill it in? Yes, this is going to be a closed circle because it has the less than or equal symbol. So now all we need to do is we need to create our shape and connect it. There. There's our first piece of our piecewise step function. Next up, we graph the other one. So once again, we just create our t-table, our XY t-table, our input-output t-table, and it says greater than 1. So let's put 2, 3, 4. If we plugged in -2, we get -2 plus 3 is 1. If we plugged in 3, -3 plus 3 is 0. If we plugged in 4, -4 plus 3 is -1. But we want to get to 1, but not include it. So we have to plug in 1. So if we plugged in 1, -1 plus 3 would give us 2. So now let's graph these. Now, because it doesn't have the equal sign, we're going to do an open symbol on there. So at 1, it's going to be open at 2 right here when x is 1. When x is 2, it's going to be at 1. And so on. 3, 0, 4, -1. And once again, we are going to graph our line. It is a linear equation. So here's our line. And here's our function. Our function looks like this. But there's two things we forgot to say. Hey, this is going to keep going. X is going to keep going to the left as x decreases. Y is going to decrease. And when x increases, y is going to decrease. So now we can state some things. All right, it's going to go forever down. It's going to go forever left. It's going to go forever right. But we understand that it's not going to go past the 6. So our range doesn't go above 6. So let's write this in. Our domain, since it's going to go forever left and right, our domain is going to be all real numbers. And now that would look like this, like x will be -infinity and positive infinity. You don't need to write that though. Now our range is going to be, a limit of 6. So it's going to be our y is going to be at most, but it's going to equal 6. And then it's going to be everything down. All right. And then it's almost as if the only part, there's nothing that overlaps, so it's still a function. When we do a vertical line test, it only touches this function once in our vertical line test. Every input only has one output. Even this point right here, let me circle it in green. Even this part right here, it might look like it touches it twice, but it's technically not here. It's at 1. Our limit, it's going to get really close, and it should, like this one should be 1, 2, but it's not. It's 1, 6, because at this point, it jumps up to here. Hi guys. Thanks very much, and I'll see you guys later in class. You guys have a good one. Bye.